Okay, so problem 3. For a given variable, solve this. A lot of students just solved these equations. These are just equations. Like, you're using your simplifying steps to solve these equations. And some students were just using some students were just doing this like a normal way. They were removing balance sets just like we normally would because they had calculators. The purpose of the lesson, though, the reason why we included these in here was to show when you see something that's like a big scary, when you see something that has these big scary decimals that a lot of students feel very unsure about, one thing that you can do to get rid of decimals is to try to turn them into whole numbers. And so to do that, what they want you to do, or one way to do it, is to multiply both sides by whatever the furthest decimal place is. So in this case, all of my decimals are in the tenths place. So because of that, I decided to multiply everything by 10. 12.8 times 10 turns into 128. Notice it looks the exact same, but there's just no decimal in it. But I also have to do 10 times 6x, and I know 6 times 10 is 60, so this is going to turn into 60x. And then 14.6 times 10 is going to turn into 146. So some students just become, even though like you should come up with the exact same number either way, sometimes this is just less intimidating for students. So that's why we went over it. But now I would need to remove balance sets. I see I only have x's on the right, or sorry, on the left. So I'm going to get rid of all of my ones on the left and put all of my ones on the right. So no more ones on this side. So I'm going to subtract 128 from the left, and then I'm going to subtract it from the right to balance it out. And I will be left with just 60x on one side, and 60x is going to equal 146 minus 28, which is 18 on the other side. And then when now I need to get rid of the 60. It's 60 times x. So I am going to divide by 60 on this side and divide by 60 on this side. And then I should get x. And then 18 divided by 6 would be 3. 18 divided by 60 would be 10 times more, so or 10 times less because we're dividing, so it would be 0.3. So that should be my answer here. Some students came up with 0.33, like 0.3 repeating. Students that were doing that is not a close enough answer. Students that were coming up with that number were coming up with it because they did math wrong somewhere else. If you said 0.3 repeating, you got this one wrong. Moving on to B, let's see, for B, same thing, right? In this case, over here, we were trying to turn these into whole numbers. That's what we want to do here too. I see that we're dividing by 6. There's lots of ways to solve this one, but the way that we were teaching in class, if you did it a different way, it's fine, but we were teaching that because we have something getting divided by 6, we should multiply by 6 to undo that. And so we have to multiply 6 times 9, which is 54, and 6 times h is 6h, divided by 6 is just h. So when you do 6 times h divided by 6, it just turns into regular h. These two things cancel out, and all you have left is h. 6 times 99 is 6 times 90 is 540. 6 times 9 is 54. When you add those together, you get 594. And then if I subtract, and then that's my equation with whole numbers, and it's less scary. And then if I subtract a balance set from both sides, I come up with h just by itself is equal to 540. So that's what you should have come up with here. A number of students came up with h equals, there were a lot of students that came up with, I think, h equals 90 or h equals 15 because they forgot to cancel out this 6. And so they, and so when they did that, they ended up with h over 6 equals 540, and then they divided by 6 and got 90. And some of them got 90 here and then divided that by 6, and they got 15 instead. Those ones are obviously incorrect. Okay, the last one is the one where we sort of start putting all this together. I need to get rid of all of these things that are being divided all at the same time. And so what we talked about in class, there are lots of ways to do it, but in order to get rid of this 3 and this 7, in order to get rid of the 7, I have to multiply by 7. In order to get rid of the 3, I have to multiply by 3. And in order to get rid of this 21, I have to multiply by 21. But I have to multiply everything by all those things. But if there's one number that I can that's divisible by all of these, I can just pick that. So 21 is divisible by 21, 7, and 3. And so if I multiply by 21 here, then what I'll do is I'll do a little cancellation. This 21 divided by 7 turns into 3 times 8a. And 21 divided by, let's get another red. 21 divided by 3 turns into 7 times 2. So instead of it being 21 times 2 divided by 3, it's now just 7 times 2. And then on the other side, 21 divided by 21 is 1, so this just turns into 62 times 1, which is 62. Let's see, 62 times 1 is 62. And then now I just do this simplifying math, right? I know 7 times 2 is 14. I know that 3 times 8 is 24 times a is 24a. And I know 62 is 62. So what I've done is by multiplying by 21, all of my terms, this is plus. All of my terms when I multiply by 21, this term is now 21 times bigger, and when it gets 21 times bigger and you simplify it, it turns into 24a. This term here is 21 times bigger, it turns into 14. And this term here is 21 times bigger, it's just 62. So because both sides got larger by 21, that means like this is still a balanced equation, because if one side of the teeter-totter gets bigger, the other side can also get bigger. So then I need to just solve. So I subtract 14 from both sides, and I get 24a equals 62 minus 14, which is 48. And then I get rid of this 24 by dividing by 24. Divide this side by 24. And so a should equal 2. And that should be your solution. Okay, so for this problem, now we get into some percent proportions. Griffin gave his waiter a $12.76 tip for a $53.17 bill. What is the percent of the tip that he gave? So there are multiple ways to figure this out. As we've been thinking about associating numbers or associating the different quantities, if I am going to associate monies with percents, then the $53.17 amount of money is associated with 100% of the money that you have to pay for your meal. And the $12.76 money is associated with an unknown percent, so we write X percent here. But it is that's the question, what is the percent of the tip? But this is associated with the tip. So if we were to solve this using any of our other methods, one thing we can do is we can find out what our scale factor is. So I like to use the C method to figure that out. So I would do 1276 divided by 53.17, and what that tells me is, what would I multiply 53.17 by to get this? And then I'm going to multiply the other side by the same thing. So when I type that in, 1276 divided by 53.17, I get 0.2399. I get 0.23998. All these 239, it's like 984, but I'm just going to, I think it would probably be safe to get rid of all of that and just round it up to 0.24. And then, so that is my decimal value of my scale factor, right? That means 12.76 is 0.24 times $53.17. So if I multiply this times 0.24, if I multiply 5317 times that, I should get 1276. So then I should do that here, and if I do 100 times 0.24, I will get 24%. So this is a 24% tip. But there was another way that students were doing it that I really liked, where they were associating these differently. So they would associate, let's see, the 100%, instead of associating it with the money vertically, they were associating it across. So it was going 53.17. And then the X percent, the unknown percent, was going with 1276. And so if you just solve this, it's actually going to give you your percent. So if you do 12.76 divided by 53.17, you should get that same really long 23.9 whatever percent. So 0.2399842 or 9984954. I'm rounding it up to 24%, or 0.24, which equals, 24%. So if you just said 0.24, you might have gotten you probably got some partial credit for that, but 24% is the correct amount. It is not 0.24%, and it asked for the percent, so you needed to give me that. Reverse them. So apparently the problem on the quiz that you guys took says it started at, you have a deli platter that started at 1950 and it went to 1125. And it asks, what is the percent change? So there's two ways to figure this out. One of them is to say that it started at 1950, and the change is, in order to find out what the money change is, I subtract and I get $8.25. So this is the price change. Now, if I wanted to figure out, so it asks for the percent change. And so what that means is, it doesn't mean what is the percent of the new price. It means what percent did the price change. So if this is the change in money, then what I want to know is what is the percent that goes with this. So if I was going to set up my proportions, there's another way we can solve this, but I'm going to do one first. We're going to do, so we have 1950, and we know that goes with 100%. That was the original price. And then I don't know what the percentage is that goes with the change in the price, which is $8.25. So if I solve this using, say, the C method or something, let's use a different color here. If I use the C method to solve this, then I get I would do $8.25 divided by 1950, and I would find out what the multiplier is. So I know that that 19.5 times what I get, when I do that is so 825 divided by 1950. That is going to give me 0.42, and then 0.423 really. And then when I multiply that times 100%, so what this means is that my multiplier, when I go this way, I am multiplying times 0.423. So I'm going to multiply 100% times the same thing, also times 0.423, and I get 42.3%. So that is the percentage that goes with the change. So the percent change here is 42.3.